Hello everyone. So last time we covered the topic time dilation and length contraction. Also we discussed some questions on the same topics. And today we're gonna start in the lecture 4 about the relativistic addition of velocities in 3D. Okay, if two particles are moving in the 3D space and they have vector notation and their vectors in the 3D space, then how are you gonna transform the or you how gonna you gonna find the velocity of one with respect to other, okay, in 3D. So let's see, if there are two frames. This is S frame, this is S prime frame, and this frame is moving. Okay, not exactly moving. First let's see, in S frame there is this point or particle which is moving with speed u. Okay, so the vectors will be uxx cap, uyy cap, and uz cap. And its coordinate, this particle's coordinate in this frame, S prime frame, will be ux prime, uy prime, uz prime. And this frame is moving, S prime frame is moving with v velocity in the x direction. Okay, now see, ux equal to dx by dt, uy dy by dt, and uz dz by dt. Same, in the ux prime we will find dx prime by dt prime, same. Okay, now from the Lorentz transformation we know that transformation in coordinates is x prime will be x minus vt by root 1 minus v square by c square. So from here we will find dx prime, that will be dx and dt here, so dx minus v dt and 1 minus v square by c square. Now t prime in the Lorentz transformation is t minus v by c square x divided by this. So from here dt prime will be here dt and here dx, and it will be given by this expression. Now the y prime and z prime will remain same because our frame is moving in the x direction. Okay, that's why y prime and z prime will remain same. Then y prime is y, dy prime will be dy, dz prime will be dz. Okay, now we have to find its velocity components in s prime frame. In s prime frame, then ux prime will give that, and uy prime will give the y component, uz prime will give z component. Okay, of this particle. Okay, ux, and it was in ux was in s frame, then ux prime will be in s prime frame. Okay, so let's see, ux prime is dx prime by dt prime. So from above we will find that dx prime is this, so right here, and dt prime is this. So the denominator component will be cancelled, and we will remain with dx minus v dt divided by dt minus v by c square dx. Okay, now from here we will take dt common, so we'll find that here it comes dx by dt, and here is 1 minus v by c square dx by dt. And what's dx by dt? It is ux. So ux prime will be ux minus v 1 minus ux v by c square. Ux is what? The x component of p particle in the s frame, and it is the x component of p particle in s prime frame. Okay, so ux prime will be this. Same for uy prime, it will be dy prime by dt. Here we will see some difference, as we know that time component is only gonna vary for the x direction, because this frame is moving in x direction. That's why only the x component is gonna with time, and time is gonna vary with this. So we find that uy prime is dy prime by dt prime. So dy prime is dy, it will remain same, and dt prime is this. So this will come in denominator and it will go upward, it will come to this expression. Okay, now from here dy prime will be, take dt common, and here will be 1 minus v by c square dx by dt, and upper it will be uy. So we got the transformation from uy to uy prime. Uy prime will be u by root 1 minus v square by c square 1 minus v ux by c square. So all components, this denominator part will depend on ux. Okay, because our frame is moving in x direction, that's why. And there is this time dilation, all things will be in x direction only. So uz prime will be same as the y factor. We will get with uz root minus v square by c square 1 minus v ux divided by c square. Okay, hope it is clear to you. Now let's see some questions, then it will be more clear to you. Two relativistic particles are traveling with same speed v in direction perpendicular to each other. Two particles are moving perpendicular to each other relatively. So relative speed of one with other is, so there are two particles, let's say p and q are moving perpendicular to each other. Okay, we have to find the velocity of one with respect to other. So let's see, q particle is moving in this side, so make this q particle a frame. This is earth frame, we will call it s frame, and this q particle as s prime frame. So q particle is moving and we placed our frame on it. Now p particle is moving in two frames, in the earth frame and the s prime frame, and we have to find the speed of p with respect to q. So we will find the s prime, we will find the components of velocity in s prime frame. That will give us the speed of p with respect to q also. V of p with respect to q is equal to vp with respect to this s prime frame, and that will be up prime. So we have formulas, uy prime, uz prime, ux prime is this, and we will get components for vp as up equal to 0 x cap 0 z cap, and is moving only in y direction. So in s frame, component of p will be ux cap vy cap 0 z cap, and up prime frame we will get ux prime frame, ux prime, uy prime, uz prime. Now we have to find the values of these threes. So ux prime will be ux minus v divided by minus ux v by c square, because we know the formula here, ux is 0 and v is the speed and on which the frame is moving, and this is the formula, so we will use it here directly. From here ux is 0 minus v 1 minus this will give us 0, and it will come as minus v, so x prime will minus v. Ui prime will be this ui prime. From here we know that this is this, and ux is 0, ui is v, so we will get as v root minus v square by c square. Unit prime will be 0, so we will get these three, v minus v, this and this. So if we wanna find the absolute value, then we will just take the root of the square of these, so we'll get the magnitude. Okay, let's move forward to the next question. Spaceship S1 leaves the earth along the x direction. Another spaceship S2 leaves the earth along the direction which makes an angle of 60 degree with x-axis. Speed of S1 and S2 are measured 0.6 c and 0.9 c respectively. Find the speed of S2 as measured by an observer in S1. Okay, the given is that a spaceship is moving in x direction with this speed, and another S2 spaceship is moving with respect to earth in the 60 degree angle. So we have to find just speed of S2 just to S1. So what will we do? We will make it as S prime frame, and we will find the component of this in S prime frame as we did in the last question. Here if it is moving with 0.9 c, then we have x component as 0.9 c cos 60 and y component 0.9 c sin 60, and the z component is 0, so u s2 prime. So speed of s2 in s frame is this, and us2 is this. Okay, cos 60 sin 60 value. Now same formulas, ux prime and uy prime and uz prime, and then take the root for these speeds and you will get the absolute value. I hope it is easy, because once the concept is clear, then it's not that hard. It's just you need to understand the logic, then you will be able to solve any of the questions related to this. Let's take one more example. In the laboratory frame, two observers A and B are moving along the side of equilateral triangle with equal speed c by 2 as shown in the figure. The speed of B as measured by the A will be. Okay, so B is moving in this direction, A is moving in this direction. It is an equilateral triangle, so this will be 60, this will be 60, this will be 60. Okay, now this is moving in this direction, and what is asked? It is asked that we have to find the speed of B. The speed of B as measured by A is. Okay. So we will take A as the S prime frame and we have to find the speed with B. So we will find the speed of B in the S prime frame. We will take it as S prime frame. So let's make it I let you so let me show you. Here is this S frame. Okay, and just take this vector A vector, tilt it to the horizontal, and it will give us like this. Okay, then we will see if it will go like this, then this will go like this. So we put our S prime frame on A and we have to find the speed of B with respect to A. So we will find the component of B in S prime frame, then that will be our answer. So if this component is this and this is angle 60 degree, then B will have what, c by 2 cos theta in this direction, c by 2 sin theta in this direction. So components will be minus c by 2 cos 60 because this is in this direction, and plus c by 2 sin 60 above, and 0 z cap. So these are the components, and speed is given v equal to c by 2, and u b with respect to a is 0 b prime as I told you earlier. Okay, so now we have to just find the component in this frame S prime frame of this, and we know the ux and uy and uz, so we can find the ux prime, uy prime and uz prime and take the under root of the squares to find the magnitude. Okay, you will get the answer. Let's move forward to the new topic. Well, it's not new, just you need to understand the rest mass, moving mass, energies, momentum, how they are related in the relativistic arena or the relativistic frames. Okay, so just note down these points, these are very important. At rest of any body, we will call its mass as m naught, that is called the rest mass. Relativistic mass, if the mass is moving, then it will given by m naught divided by 1 minus v square by c square. Here m naught is the rest mass. Relativistic momentum will be mv. This is actual mass. Now that will be m naught v by root 1 minus v square c square because of this moving mass. The original mass will be m naught by this. And if we divide its component, then px will be this, py will be this, pz will be this. Just divide these components of v. Now the relativistic force, that is dp by dt. Here p is mv, so put the m value, m naught by this, and it will give us the relativistic force. Now this is very important, the total energy. Okay, so from the Einstein's equation we know that total energy of any particle, anything, given by this formula mc square. Here m is the mass, relativistic mass, and c square. M is given by m naught by root 1 minus v square by c square and c square. Okay, Einstein's relation. Now there are other formulas also to give the total energy, that will be equal to k plus m naught c square. Here m naught c square represents the rest mass energy, k is the kinetic energy of the particle. Okay, so total energy will be sum of these. There is one more formula, that is equal to root pc square plus m naught c square ka whole square, and that will be e square c square plus m naught square c4. It's also given, total energy given by this formula. So we use these formulas as per our comfort, and the depend on the questions that which will be easy to give the solution. Okay, so that will be that will we use here. Now from seeing any equation or any particle, how will you say that this particle is in the relativistic motion or not, or this is relativistic case or not? So if PC is less, very less than m naught c square, then we will call it the non-relativistic case. And if PC is approximately equal to m naught c square, nearby m naught c square, or greater than m naught c square, then that case will be called relativistic case. It is asked that how can you define that something is relativistic or not, so you can give this is the exact answer for that. Okay, now k equal to p square by 2m, we know this formula for the kinetic energy. Okay, so this formula is not valid in the relativistic case. It is only applied when the speed of light is very, oh sorry, speed of object is very small relative to light. Okay, now hope it is clear. Now we will see some questions, so this will be more clear to you, these equations, how we gonna use them and how it make things easy. So first question is, kinetic energy of particle whose rest mass is m naught is equal to its rest mass energy. Find its momentum in units of m naught c. So from the kinetic energy formula, we know that total energy equal to kinetic energy plus m naught c square. So we'll write it here, k equal to E, from here k equal to E minus m naught c square. It is given that kinetic energy of particle rest mass m naught equal to its rest mass energy. So kinetic energy we will write at m naught c square because it is equal to rest mass energy. From here we will get total energy as 2 m naught c square. Okay, now we have to find its momentum, so we will use this equation and put equal to the total energy, that is 2 m naught c square, and we will get our answer, that will be p equal to root 3 m naught c. Okay, the next question, two particles each of rest mass m collide head on and stick together, so that will be an inelastic collision. Okay, because they are not together, so they are not moving separately. Before collision, the speed of each mass was 0.6 c. Find the mass of the final entity in terms of the m. So this m is rest mass. Okay, it is given that two particles each of rest mass m collide head on and stick together. Before collision, the speed of each mass was 0.6 c. Find the mass of the final entity in terms of m. So these are two masses moving towards each other, gonna head on collision, and it is moving with 0.6 c, and it is also moving with 0.6 c. So we have to find that after the collision they put together and then move together. Okay, so we have to find the mass of that entity formed. So initially in the inelastic, or whether it is elastic or inelastic, we know that momentum will always be conserved. So we'll find its momentum, initial momentum of this system. P1 is equal to m 0.6 c and divided by this. P2 will be this, that will be in negative direction because both will add up to give net momentum as 0. Okay, so we know that initial momentum is 0, so final momentum is also 0. Pf is equal to 0. So final energy we will find that Ef equal to, if Pf is 0, then final energy will be mc square. M is the mass of that entity, so we have to find this m. Now initial energy is also mc square, and here m is relative mass, relativistic mass, that is m by this c square plus the energy of second particle is this, and this will be equal to the final energy mc square. From here we can find that capital M will be 5 by 2m, 5 by 2m. So it is easy. Let's go to the next question. Now there is this question, let v, p and e denote the speed, the magnitude of momentum and the energy of the free particle with rest mass m. Then which of these are correct? Actually this was the question asked, that which of these are correct or which one is correct. Okay, so we have to see, as it is given that free particle rest mass is m, rest mass is m, so momentum will not be this, because momentum for the m rest mass is m divided by 1 minus v square by c square, so this is wrong. Equal to mc square, this is also wrong because it is root 1 minus v square by c square for rest mass m. And from here it can be found from this formula here, dE by dP, if you find, then it will also depend on p, it won't be constant, so this is also wrong, this is wrong, this is wrong, so this will be the right answer. You can find it from that formula, you will get that it is correct. Now one more question is here, A stationary body explodes into two fragments, each of rest mass m. Two fragments move apart at a speed eta c, and that is eta is greater than 0 and less than 1. Relative to the original body, rest mass of original body is. Okay, so there is this stationary body which explodes and move in this opposite directions, and that two objects with rest mass m. Two fragments move apart. Their well speed is in eta c, and now we have to find a relative. We have to find the rest mass of original body, the m, capital M. So here is this body. This explored with eta c there, eta c this side, and initial momentum was 0 because it was not moving. So final momentum should also be 0. So and initial energy should equal to final energy. Final initial energy was capital MC square, and now energy of this is mc square divided by root 1 minus speed square, that is neta c. So neta square c square divided by c square will cancel out, so we'll get 1 minus neta square plus this energy mc square. This will be same. From here we can find you can find the capital M value. Okay, that was the asked. Rest mass of original body is, so that is capital M. You can find its value from here. C square will cancel out, and you will get your answer, that will be 2m by root 1 minus neta square. C will be the answer. Okay, 2m by root C will be the answer. Okay, we will end it here today. In the next lecture we're going to discuss some more questions and some new topics also. We're going to study like Minkowski space, the 4D space, and the Doppler's effect. These are the some of the topics remaining, so we will cover in 3 to 4 lectures. There will be not more than 9 lectures for this, the STR. Okay, so just be consistent and follow the lectures. Just follow what I am telling you or what I'm teaching you. No need to go for more or more practice sets, and that's all. You just need to solve these questions which I am providing you. Okay, so thank you.